Okay, hi and Assalamualaikum. Welcome to our group HG14. For our integrated design project, our group choose to make a project title which is Automatic IV Monitoring and Data Logging System.
We present our design journey for the automated IV monitoring and data logging system. We apply the design thinking methodology to solve a critical issue in healthcare management. So our journey started with empathize. We look at the daily challenge faced by doctors and nurses. We realized that manually monitoring IV fluid levels is time consuming and prone to human error. More critically, if an IV bag runs empty unnoticed or the flow stops unexpectedly, it poses severe risks to patient safety, such as embolism. Healthcare staff are burdened and need a way to monitor patients effectively without being at the bedside 24/7. Next, in the define phase, we formulate our key problem statement. The traditional method of checking IV drips relies heavily on visual inspection, which causes delays and increases the workload on staff. Our goal was clear: to create an automated system that counts IV fluid levels, logs data, and sends instant alerts, reducing the burden on staff while enhancing patient safety.
Okay, in the idea generation phase, various IV monitoring techniques were assessed, including a drip sensor and a camera-based monitoring. But these two methods or approach can detect IV flow, but they lack of accurate fluid quantification and automated documentation. As a result, we choose to use a smart IV monitoring system that employing a load cell and HZ711 amplifier was selected. The major IV bag weight is processed by an ESP32 and automatically logged into a Google Sheet with timestamp, it enabling the real-time monitoring and digital recording keeping while reducing a human error in manual IV charting.
For the prototype concept, our proposed system uses a load cell to measure the IV bag weight continuously. The data is processed by ESP32 microcontroller and sent to the cloud platform, that is Google Sheet. The system determines whether the IV status is normal or not normal and automatically send the data with a timestamp. As we can see from the block diagram, the power supply and the load cell goes to the ESP32, and the output will be the buzzer, LED and OLED display. The data that is being processed in microcontroller ESP32 will send notification to the Blink and also in the Blink to our phone, and also we send the data to the Google Sheet.
Alright, now I'm going to present about the step analysis test validate. Alright, first of all, it meets critical needs, reducing nurse workload and improving patient safety. And then socially, it cut down manual work. And then for the technologically, it's powered by IoT and cloud data logging. Economically, it's low cost. Environmentally, it moves us away from paper reports.
For NABC analysis part, for the need, manual IV monitoring is prone to human error and staff shortage. It includes a patient safety risk. So, to improve this, we use an approach. We develop a low-cost IoT IV monitoring system. Okay, so here is our system controller interface that we designed in Blink. Okay, to start the system, we need to turn on the push button on the mobile apps. Okay, after we start the system, as you can see, if you go to Arduino IDE, in the serial monitor, we can see the system load cell and HZ711 sensor start working. Initial weight will be 0 because the system will not point the IV bag yet. In the display box, LED will turn on, OLED start with display. It will indicate the system is start restarting. After we know the system is restart, we can install the new IV bag. After we install the new IV bag, we can see the real-time monitoring. It will display the amount of water that have in the water bag. Then we start open the valve to simulate the water dripping to the patient. The remaining IV water in the bottle can be monitored in the display box. And also, this IV drip process can be monitored remotely at the water level gauge in the mobile apps. Okay, if the IV drip process running smoothly without any interruption, the OLED will display 0 ml and status low fluid. And in the apps mobile app, it will appear the notification said that the alert to doctor that the IV drip process is come to the end. After the doctor will turn off the system, and we can see the system start restarting and turn off. After the turn off, the system will reset the IV drip process and the data will send to the Google Doc. Okay, if the second scenario occur, which is the IV drip block, as we can see, the IV drip has problem or blockage, the system will give notification to the nurse. First, the OLED will display drip block and it will display the notification to the nurse or doctor through the mobile apps. Okay, for this project cost estimation, we only use around RM91.45. It's a low cost project because for the stand and the box, we use a recycle item. For the stand, we use a PVC that we can find in recycle, and also the box we recycle the other project box, so that we can apply a very low cost and we can recycle the things. And the price RM91.45 only go for the component, to buy a component such as ESP32 and the sensor for load cell and HG14. It's as least as here.